All right, welcome everyone. Today, we're really rolling up our sleeves for a highly practical, over-the-shoulder coding workshop. We're getting hands-on with LangGraph to understand exactly how to build and orchestrate some seriously powerful AI workflows.
Think about this for a second. How do you actually build truly autonomous AI agents? I'm not just talking about your basic chatbots that answer a single prompt and, well, stop. I'm talking about AI that can actually think, evaluate its own work, loop back around to correct mistakes, and act dynamically. Traditional, predictable prompts and linear chains, they just aren't enough for these complex applications. You absolutely need a system built to handle dynamic reasoning.
Okay, let's dive into this. Look at the fundamental difference between these two approaches. Traditional workflows are strictly linear. They run a single, predictable path from start to finish. User input goes to an LLM, maybe it processes the output, and then it's done. It stops. It's predictable, sure, but it's really rigid. LangGraph, on the other hand, introduces cyclical graphs. This is a real game changer because it means your agent can loop, branch out, research data, split tasks, synthesize information, and dynamically decide what to do next based purely on the current state of the workflow. So here's our step-by-step roadmap for today's interactive build. We're going to define what LangGraph is, prep your workspace, build your first workflow, master the loop mechanism, add some human-in-the-loop oversight, and finally, cover tracing with LangSmith.
Let's kick things off with Section 1. What exactly is LangGraph?
I absolutely love the simple formula straight from the documentation. LangGraph equals LangChain plus graph-based workflows. Ultimately, it's an orchestration framework designed to build intelligent, stateful, and multi-step LLM workflows. And by stateful, I mean it provides a highly structured approach with full state management. So your agent literally always remembers where it is, what data it's collected, and what it needs to execute next.
And this brilliantly illustrates how it actually works under the hood. It literally converts any LLM workflow into this beautiful graph structure. It's kind of like a giant puzzle. The boxes are nodes, and these represent specific tasks, like, say, making an LLM call or executing a Python function. The arrows connecting them are edges, which define the strict flow of execution between those tasks. It is exactly like mapping out a logical flowchart for your AI's brain. All right, moving right along to Section 2, prepping your workspace and getting that development setup dialed in.
First things first, open up your terminal to create and activate your virtual environment. Then install your core libraries using pip. Specifically, you'll type pip install LangGraph, LangChain, LangChain_OpenAI. Finally, set up your project structure. Just create a root folder containing a .env file for your API keys, your backend Python file where the workflow is going to live, and a front-end file.
As you'll see here, this timeline maps out exactly what we just built. It takes you from folder creation all the way to launching code. Virtual environment creation, library installations, project structure setup, configuring and verifying your API keys, and boom, you are ready to start coding. Setting this foundation correctly up front prevents endless debugging later on, for sure. Now that your workspace is good to go, let's jump into Section 3, building your very first workflow. Before we write the actual logic, let's isolate the fundamental building blocks you'll be typing into your backend Python file. You're going to import and use StateGraph. This is the absolute core component for building any workflow in LangGraph. You'll also use start and end, which are special built-in nodes marking the strict boundaries of your workflow. And you'll use Python's typed_dict to ensure your state definitions are entirely type-safe.
Okay, here is the exact four-step formula required to implement your very first linear workflow. Step 1, define your state. What variables and data actually need to be passed around? Step 2, create the graph by initializing your StateGraph object. Step 3, add your nodes and edges. Remember, nodes are the actions, edges define the order. You'll set up a sequential connection from start right to your node and then to end. And finally, Step 4, compile and execute. Follow these 4 steps and you've got a working LangGraph implementation.
Step 1 is officially in the books. Now let's move to Section 4 and see how this builds into adding loops for true autonomy. Demystifying loops in LangGraph is actually pretty straightforward. It's all about manipulating your edges. Let's say you have an agent that writes a draft and then evaluates it. To create a loop, you first create a conditional edge. This edge checks the evaluation. Is the draft good enough? If yes, route it to the end node. If no, route it to an optimized node. Then you just create a normal edge, routing from that optimized node right back to evaluate. The AI will just naturally continue to loop, evaluate, and optimize until its conditions are completely met. Next up is Section 5, adding a human in the loop or manual approval. Now, what's really interesting about this slide is what happens when you're building something sensitive. You probably don't want total autonomy just yet, right? You need to pause the workflow. When the system hits an interrupt, say right before posting a live tweet, it doesn't just crash or time out. A component called the checkpointer steps in. It saves the exact state of the graph right down to the variables at that very moment. The graph essentially goes to sleep, securely holding your data, just waiting for your manual input.
Okay, that sequence diagram had, 16 technical steps? That can definitely cause some cognitive overload. So let's synthesize it into 4 practical macro actions for your code. First, the user enters a topic. Second, the agent generates a draft using a research node. Third, the system hits an interrupt. It actually displays the draft on your UI, asking for your approval. Finally, if you say yes, you pass a resume command, the checkpointer instantly loads that saved state, and it executes the final post node.
And that brings us to our final technical milestone, Section 6, Tracing with LangSmith for Graph Observability.
So the crucial point is, once you build these autonomous looping agents, you absolutely must have a way to debug them. LangGraph and LangSmith are developed by the exact same team, giving you incredibly tight integration. You just need to remember 2 simple translation rules. Principle 1, when you execute your entire graph from start to finish, that complete execution creates one single trace in LangSmith. Principle 2, every individual node that executes during that trace equals 1 run. So if your graph loops and executes 5 nodes, your trace will clearly show 5 runs. This makes debugging incredibly efficient.
Well, we've covered the core fundamentals, from setting up a clean environment to building dynamic loops and implementing human oversight. Your environment is conceptually set, and you have the practical step-by-step formula in hand. So my final question for you is, what agent are you going to build first? Take these concepts off-screen, open up your IDE, and start writing your nodes and edges. Thanks for joining me for this explainer, and happy building.